Hey everyone, and welcome to another deep dive. Today we're going to be looking at something pretty amazing. It's the connection between electrophysiology and mental health.
Oh,
And we're using some really fascinating research that was recently published by Stanford University.
it was pretty cool.
Yeah, so just imagine if we could get objective biological clues about someone's mental state,
Hmm.
Almost like a blood test. But for things like depression or even suicidal thoughts.
Yeah, that would be a
That's the potential of this field.
huge shift. I mean, think about it. We rely so much on, self-reporting and observations from clinicians and things like that. But to actually have measurable biological markers to supplement those traditional diagnoses.
Yeah, absolutely. Okay, so let's back up for a second. What exactly are electrophysiological measures?
Well-
And how do they even work?
They basically measure electrical activity within your body, specifically in your nervous system. So you're sort of listening in on the electrical conversations that are happening
Oh, wow.
in your brain and in your body.
So we're talking about brain waves and things like that.
Exactly. So one technique that I find particularly interesting is electroretinography,
Electroretinography.
or ERG.
Okay.
And this measures the electrical responses of cells in your retina when they're exposed to light.
So like an EKG, but for your eyes?
Yeah, exactly.
Okay. So what's the connection with mental health?
Well, researchers have discovered that people exhibiting suicidal behaviors often have a much faster response in their retina to light compared to other people.
Wow.
So it's a really surprising link, and we're still trying to understand exactly what it means.
That's pretty wild. Just from looking at how your eyes respond to light, we might be able to get clues about your mental state.
Yeah, it's really interesting.
That's incredible. Okay, so are there other measures like this that can give us insights into mental health?
Absolutely. There's another one called electrodermal activity, or EA.
EDA.
EDA.
Okay.
And you know that clammy feeling you get when you're nervous?
Yeah.
EDA is measuring those tiny changes in your sweat gland activity.
Oh.
So it's giving us a window into your emotional responses.
Okay, so sweaty palms, I get that. But how does that relate to something like depression?
Well, in people with depression, they often show less of this sweat response compared to those without depression. And it possibly reflects differences in the way that their nervous systems process emotions.
So their bodies are less reactive to emotional stimuli.
Potentially, yeah.
That's a fascinating connection. I would have never thought sweat could tell us so much about what's going on inside our heads.
Yeah.
But what about directly measuring brain activity?
Well, that's where electroencephalography, or EEG, comes in.
Okay.
And this uses electrodes that are placed on your scalp. And we can actually record the electrical chatter of your brain.
Oh.
It's like tuning into different radio frequencies. And these different brainwave patterns can tell us a lot about your mental state.
Okay, I've heard of EEG before, but I always pictured it as something used for sleep studies and things like that.
Yeah.
How is it useful for understanding depression?
Well, depressed individuals often show distinct brainwave patterns. So, for example, there might be increased activity in certain frequency bands, like theta and alpha.
Yeah.
And this could reflect changes in brain areas that are related to mood regulation.
So just by analyzing these brainwave patterns, we could potentially identify signs of depression.
Precisely.
Wow.
And what makes this even more exciting is the potential of machine learning.
Okay, machine learning. Everyone's talking about it, but how does it actually work in this context?
Well, imagine you have a massive amount of EEG data from hundreds of people.
Right.
Machine learning algorithms can analyze this data and search for subtle patterns and connections that human eyes might miss.
So it's like having a superpowered detective looking for clues hidden within the brainwaves.
Exactly.
Okay, what kind of things can it tell us?
So in some studies, these algorithms could differentiate between depressed and healthy individuals with over 98% accuracy.
98%.
98%.
That's incredible.
Which really highlights the potential for these objective data-driven diagnoses.
Wow, it sounds like these algorithms are giving us a level of insight we've never had before.
Absolutely. Yeah. And the possibilities go even further. We can also apply these techniques to the incredibly important area of suicide risk assessment.
Okay, that's a topic that hits close to home for a lot of people. So how can electrophysiology help with something as complex and sensitive as suicide risk?
Well, traditional assessments often rely on self-reporting, which can be unreliable for various reasons.
Right.
But electrophysiology offers the potential for objective biomarkers. So, for example, remember that faster retinal response to light we talked about earlier?
Yeah.
That's actually showing some promise as a potential indicator of suicide risk.
Wow. So by combining these different electrophysiological measures, we could get a more accurate picture of someone's risk level.
Exactly. And it gets even more exciting when we combine electrophysiology with other fields like genomics and neuroimaging.
Wow.
So imagine layering all that data together.
Yeah.
Genetics, brain structure, and real-time brain activity.
That's a really powerful combination. Okay, so before we get too far ahead of ourselves, let's just make sure our listeners are on board with the key takeaways from this section.
Of course. It's important to remember that this is still an evolving field.
Right.
And the research is promising. But we need larger scale studies and more standardized methods to validate these findings
Well, of course.
before they can be widely used in clinical settings.
So a healthy dose of cautious optimism is in order.
Yeah,
We're excited about the possibilities, but we also need to be patient as the research continues.
absolutely.
So we've covered some seriously groundbreaking stuff, like the idea that we could potentially identify depression or even suicide risk using these objective biological markers. It's like a whole new frontier in mental health.
It is.
But I'm curious, are there any challenges to actually using these techniques in the real world? It all sounds a little too good to be true.
Yeah, you bring up a great point. I mean, while the potential is huge, there were definitely some hurdles to overcome before these techniques become like commonplace in clinical settings.
Okay, so what are some of the roadblocks that researchers are facing?
Well, one of the biggest ones is standardization.
Okay.
Right now, there's a lot of variability in how these measures are collected and analyzed. So different labs might use different equipment, different protocols, or even different definitions of what's considered a normal result.
It was like trying to compare apples and oranges.
Exactly.
Yeah.
And that lack of standardization makes it really tough to compare findings across different studies.
Right.
And it could lead to some confusion in real-world applications.
Yeah, that makes sense.
But the good news is that researchers are working towards developing clearer guidelines and more consistent methods.
Okay, that's reassuring to hear. Are there any other challenges?
Yeah, another one is the need for more research, particularly large-scale studies with diverse participants.
Okay.
Because many of the studies that we've discussed so far have been relatively small,
Yeah.
which limits how confidently we can generalize the findings to the broader population.
So we need to see if these patterns hold true across different demographics, age groups, severities of mental health conditions.
Exactly. It's all about making sure that these findings are robust and applicable to a wide range of individuals.
Yeah, that makes a lot of sense. But even with these challenges, it feels like we're on the verge of something truly revolutionary.
I think so.
What are some of the most exciting potential applications you see for electrophysiology in mental health?
Well, one area that holds immense promise is early detection and prevention.
Okay.
So imagine if we could identify individuals who are at risk for mental health conditions before they even start experiencing symptoms.
Wow, that would be a game changer. That could potentially save countless people from years of suffering. But how could we actually identify those at risk before symptoms even appear?
Well, remember those specific electrophysiological patterns we talked about? Like the faster retinal response in ERG or certain brainwave patterns in EEG? Well, research suggests that those same patterns might be present even before someone develops like outward signs of depression or anxiety.
So we could be looking for these subtle clues, almost like an early warning system for mental health?
That's the idea.
Yeah.
And with early detection, we could potentially intervene with preventative measures, like lifestyle changes, stress management techniques, or even early therapy.
Yeah, I love that approach. Shifting the focus from reaction to prevention.
Yeah, absolutely.
What other applications are you excited about?
Well, personalized treatment is another area with huge potential.
Okay.
Because right now, finding the right treatment for mental health conditions can be a bit of a trial and error process.
Yeah, I can see how that's frustrating for both patients and doctors.
Yeah, exactly.
So how could electrophysiology help personalize treatment?
Well, think back to those EEG patterns we talked about.
Yeah.
Some research suggests that certain brainwave patterns might actually predict how well someone will respond to different treatments. So like medication versus therapy.
Oh, wow. So it's like having a roadmap to guide us towards the most effective treatment for each individual.
Exactly, rather than just relying on a one-size-fits-all approach.
That's really exciting. It sounds like this technology could transform the way we approach mental health altogether. Are there any other applications you think are worth exploring beyond just diagnosis and treatment?
Yeah, we've been focusing a lot on mental health conditions, but the potential of electrophysiology goes far beyond that. What if we could use these techniques to understand and even predict thoughts, emotions, and behaviors in general?
Whoa, that's getting into some deep philosophical territory.
It is.
What kind of applications are we talking about?
I mean, imagine the possibilities in fields like education.
Hmm.
We could tailor learning approaches to a student's individual brainwave patterns.
Wow.
Or think about marketing.
Yeah.
We could understand consumer preferences and tailor advertising campaigns based on their brain responses.
Those are some pretty big what-ifs.
They are.
It sounds like the potential applications are as vast as the human imagination itself.
Absolutely. And of course, as with any powerful technology, it's important to consider the ethical implications and ensure responsible use.
Yeah, that's a crucial point. As we unlock the secrets of the brain, we need to proceed with both caution and a sense of wonder.
Well said. This research isn't just about scientific advancement. It's about understanding ourselves and the very nature of consciousness.
Wow, it's been a truly mind-expanding journey so far.
It has.
But before we wrap up this section, let's just recap the key takeaways for our listener.
Okay, so we discussed some of the challenges facing the field, like the need for standardization and more research.
Right. We also explored the incredible potential applications of electrophysiology, from early detection and prevention to personalized treatments and even applications beyond healthcare.
Absolutely.
And we touched on the importance of responsible use and ethical considerations as this technology continues to evolve.
Yeah, very important.
We'll be back in just a moment. To wrap up our deep dive into the fascinating world of electrophysiology and mental health. Stay tuned. Okay, so we've been on quite a journey today exploring how electrophysiology could revolutionize how we understand mental health. From sweat to brain waves, it seems like our bodies are full of clues about our mental state. But now I'm curious about the big picture. Where do you see this research heading in the future?
It's a really exciting time to be in this field. I think the next 5 to 10 years will bring some truly groundbreaking advancements that could totally change how we approach mental health care.
Okay, now you've got me on the edge of my seat. Give us a sneak peek into the future. What kind of breakthroughs are on the horizon?
Well, one area I'm particularly enthusiastic about is the development of more user-friendly electrophysiological devices. Right now, a lot of the equipment is bulky and expensive and requires specialized training.
So not something you could easily use at home or in a typical doctor's office?
Exactly. But imagine a future where these devices are miniaturized and affordable and easy to use. You could potentially monitor your own brain activity or get quick assessments right in your doctor's office.
That would be incredible. It would make these technologies accessible to so many more people. What other advancements are you anticipating?
Another area I'm closely watching is the integration of artificial intelligence and machine learning with electrophysiological data. We've already talked about how these technologies can analyze vast amounts of data and spot patterns that humans might miss.
It's like having a super sleuth for brainwaves.
Precisely. And as these algorithms become more sophisticated, they could help us develop even more accurate diagnostic tools, predict how well someone will respond to different treatments, and potentially even identify individuals at risk for mental health conditions before they show any symptoms.
That's mind-blowing. It feels like we're on the verge of a whole new era in mental health, but I imagine there are still many unknowns and challenges ahead.
Of course. There's still a lot of research to be done. We need to fine-tune these algorithms, ensure they are ethically developed and deployed, and figure out how to best integrate them into clinical practice.
It sounds like there's a lot to consider, but the potential benefits are enormous.
Absolutely. Imagine a world where we could detect mental health conditions early, intervene with personalized treatments, and potentially even prevent these conditions from developing in the first place.
That's a future I think we can all get behind. As we wrap up this deep dive, is there any final thought you want to leave our listener with?
We've been talking a lot about the science and the technology, but it's important to remember that this research is ultimately about understanding ourselves better. It's about unraveling the mysteries of the human brain and using that knowledge to improve people's lives.
That's a beautiful way to put it. It's a reminder that science isn't just about facts and figures, but about exploring what it means to be human. Well, this has been a truly fascinating deep dive into the world of electrophysiology and mental health.
It really has. It's been a pleasure sharing these insights with you and your listeners.
We hope you've enjoyed this journey into the fascinating world of electrophysiology and mental health. Until next time, keep those minds curious